Hi, I'm Muneeb Saleem. I work as an ML engineer at Google, and this is Daftarkhwan Insights. For those who don't know, Daftarkhwan is a community of entrepreneurs and engineers who are working cool new things, and I'm thankful they invited me to this talk. I'll discuss applications of AI with an entrepreneurial lens, but also in terms of an engineer and also a researcher. So I'll start with a very high-level overview of what we think AI is and what different subdisciplines of AI are. Artificial intelligence is a very broad area. Like a lot of things that we do or we have been doing since many years ago that qualifies as artificial intelligence. My personal focus has mostly been in deep learning and machine learning, which are subfields of AI. Machine learning is basically algorithms whose performance improve as they are exposed to more data over time. So they are data-driven models. AI in general doesn't have to be data-driven. It can be anything which makes a particular product or system appear smart or appear intelligent, right? So it can involve some domain knowledge in your code, some other heuristics that you implement in your code or product, which makes it very smart. And within machine learning, deep learning is the area which deals with neural networks mostly. So when I see deep learning, I almost always have this translation in my head which says that, okay, deep learning is just neural networks. Because this is what really gave this whole field a boost in the last 10 years. Because in 2012, people realized that if they just have a large amount of data and they have a good way of training neural networks, they can beat a lot of benchmarks in terms of performance. So they started breaking benchmarks in computer vision, natural language processing, and speech recognition, just to name a few. So what was happening is older learning algorithms did not benefit a lot from very large amounts of data. But neural networks benefited a lot from just having large amounts of data. This could be labeled data or without labels as well. So much so that it actually beat human-level performance in some very specialized tasks, like image recognition and some other tasks. So this is what really brought AI and machine learning overall into the limelight in the recent years. So ideally, you want to build something which is very novel and it's very applicable to the product. But that's on a practical level, it doesn't happen very frequently. A lot of times you start with some heuristics, which is like general AI, that makes your product smart. As you grow your expertise and your resources, you get to work on applied ML, so where you actually have a more sophisticated algorithm running your product. And if you have a much larger budget or you are a research organization, then you can actually do some fundamental research, which is very novel stuff, but it doesn't have end product applications right away. So my personal journey has been the other way around. So I started with research, then went to applied ML, and then also did a little bit of heuristics, but I'll focus more on applied ML. I'll share one high-level example from my time in Volkswagen Group research. So this was a research group trying to do some applied ML as well on autonomous driving. So on the left, you can see a typical modular stack of autonomous driving or how autonomous vehicles work. You have a lot of very well-separated modules which do a very specific task, like one module which do object detection. Then you have a scene interpretation, behavior estimation and prediction, path planning, and a separate controller, and then actuation of the vehicle. So this was a very blue sky almost research project where we were wondering, like, can a single neural network do all of these things end to end? Like, can you just give them a camera sensor input and the neural network learns to drive automatically by learning from a very large amount of data? Because theoretically, if it has seen all the different things that can happen in the real world, it should be able to learn from them that and act in a similar way as human drivers, for example, drive. Because if you collect lots of data from like how human drivers drive, you can hope that, okay, with imitation learning, it can learn to imitate a human driver, right? So theoretically, it's possible. So it's learning from data and driving itself, but you also have to tell it, okay, where do you want to actually go, like left, right, straight at this intersection, similar to how Google Maps give you guidance, navigation directions. So this is a very high-level diagram of how this kind of work looks like. So it's very focused into like how to train this neural network, how to set up the data, and how to validate that its performance in different scenarios. But in most production systems, especially on the software side, there's much more involved beyond training neural networks and the machine learning algorithm. There's a lot of infrastructure that you need to collect this data, to validate your data collection protocols are useful for what you're trying to achieve, how you serve these models in production, and also how you have this how you develop the whole machine learning cycle. Like you're not going to do it just once, right? Like you train a model and then you ship it. It's a continuous improvement process. So the actual machine learning code is very small in an actual production system. A lot of work goes into just the data infrastructure because these are data-driven models. So if you feed it garbage, then garbage comes out. Typically, you start with some exploratory analysis of what kind of data you're dealing with. Then you do some feature engineering. Usually with deep learning, this step is minimal. You don't want to bake too much bias into how you are engineering these features. You want to learn from the actual raw data as much as possible. And then you train a model, you define a model. It might not work the first time, then you go back, do feature engineering again, then you train the model again. And you do this again and again until it's time, you're happy with the training, and then you can evaluate that. And during evaluation, you might find out, okay, it's not working so well. Then you have to go back to training. So it's a very continuous process. Here, I would like to show this case study of Autopilot. This is self-driving technology implemented by Tesla. So that's not a small company, but their approach is very interesting. The goal of this system is it has to keep the vehicle in the center of the lane. It has to maintain constant speed, and it should make sure it's driving in a safe way. Like if there's an object in front of you, it should not keep driving at the same speed. So it's a very hard problem, right? Like ideally, you need a machine learning system which has all these kind of detection capabilities. It needs to know everything on the road, like where the road is, where the lane markings are, where different other vehicles are, where are the barriers, and any unseen possibility that could happen in the real world, right? So in a new company, you don't have all these things. You don't have the data, you don't have the labels, you don't have a way of having all of this information to develop this like self-driving technology. You include all the hardware and the data infrastructure that is necessary for you to train these kind of ML models few years in the future. So right now, you don't have anything, right? But you can start developing that data infrastructure that you would need for those future ML features. You can then start with non-ML heuristics. So once you have these cars on the road, you can develop some heuristics which are not based on machine learning, which could be simply using some classical computer vision algorithms, for example, which detect a road or have a very minimum kind of functionality. And you don't control the car at that point. So you just run these algorithms in what they call shadow mode. What this means is the algorithm doesn't actually do anything for the user or the driver, but it allows you to measure how good your algorithm is by comparing it with the human driver's performance. So the human driver is still driving, right? But your algorithm is making some prediction. So your algorithm is predicting, hey, turn right at this point. But the human driver keeps driving straight. So if you have the data infrastructure to collect all this data, you can use it to train your own models later on. So it's not benefiting the user right away, but if you have a way to get this data, then you can train those models while you still have a product in the market. And you can keep validating your algorithm until you feel it's really good and it's almost matching the human driver's performance, for example. So here they have a way of automatically labeling all their data, right? So, and you can be more smart about collecting this data. Like instead of collecting everything, only collect data where the human driver's performance was different from your algorithm's performance. Because that means there's some room for improvement. And then, yeah, ultimately, you ship this model to the cars over the air update. Again, because you have that data infrastructure to remotely enable things through software and cloud, and everything is connected. Then you can compare your model's performance live on the road, and you can do a gradual rollout the first thing is like you have to merge your AI strategy with the product strategy. So you have a use case. For example, you want to solve this pain point of a particular user. You may or may not use AI, right? So in the very beginning, you can plan for like how these problems can be solved. Like you want to find the product market fit. So doesn't matter what technology you need. Maybe you don't need deep learning. Maybe you don't even need machine learning, right? So you can like bootstrap without ML. Like just use some domain knowledge or heuristics to make your product a little bit smart just to solve that particular problem, right? And you can even use like off-the-shelf APIs or cloud APIs or models. You don't have to train your own models at this step. And make sure that while you're doing all of these things, you have a method of collecting and validating all this usage metadata, like how your product is being used, is it actually solving the pain point, and any kind of data which might be helpful later on for actually developing these models. And whenever you have a product checkpoint, you can evaluate like how much improvement you could get if you had ML in your product, right? Because in these early stages, you really want to nail down that product market fit. And if it solves that problem without AI or without ML, that's perfect. But just evaluate like how much incremental improvement it will offer if you really have a deep neural network doing that same task, which you can also do by if or else statements, right? And that's it. So I try to make it super short so you have more time for question and answers and networking and whatnot.
Hey Muneeb, this is Salman. It was really a great talk. Thank you very much. I'm working as an ML engineer for last 4 or 5 years. So right now I wanted to develop my own product. So my first question is like how you compute feasibility of the product.
Think of the feasibility in terms of what you are proposing actually solves the user's pain point, right? Like, so you think that, okay, ML can maybe do this, then maybe you can start with the most basic kind of heuristics. So you don't have to start with a very complex model and see if it solves that, because there are always corner cases. So I would almost always start with the simplest possible model, and that is usually some kind of heuristics. Or you can have an API or an existing off-the-shelf model, and you can run that to see how well that performs. Because whatever you develop in-house, that would take a lot more resources. It wouldn't be very far from what's available out there, right? At least the very beginning. So I wouldn't, otherwise it becomes a research project. So I would always start with trying a simple model and see, does it even give you like 60% performance? And even if you want it to be like 80%, is it at least giving you 60, 70% performance? Because if it's not, then it's probably wise not to invest too much resources.
You have seen open source community, they are really active these days. So OpenAI create a model, let's say text to image, and next day open source community create their own model, which is freely available. So how you solve that problem?
I think you shouldn't start with like developing your own ML model, and that shouldn't be the main offering. The main offering should be solving end use case, because when you are trying to solve an end customer use case, you have a lot of assumptions that, hey, if I do this with an ML model, and then the customer will be very happy, all their problems will be solved. But that's not typically the case. There are a lot of corner points, and there are these preferences by a user. Like they might not be happy if there's an ML model solving that problem, or some other thing. So there are a lot of these like usability issues that come up when you're actually solving that problem, which are more important. And if you as an entrepreneur understand all those things, then I think they have a pretty big contribution to your product. Like the ML product is just a tool, right? It's just a tool to solve one problem somewhere. But I think if you understand the use case really well, like different corner cases, what is your target audience, what do they prefer, what are their like unique preferences, that's very valuable as well. So yeah, sure, somebody can copy your ML model, but you have like some other unique insights as well. So I think it's the combination of them which is a bit hard to beat.
My name is Muhammad Sufyan. I'm just a computer science student. I have seen in a video that Tesla, I think in UK, there is a buggy, so it cannot detecting it. It's just showing it's just a car or just a bike. It's just conflicting it. So I just want to share this video. What do you say about it?
Yeah, so ML models, they probably, that model was probably not trained with horse and carriages or like these buggies, right? So they kind of fail there. So there's I think the expectation for an ML model is kind of high. Like that's the hype that's created by when you see articles in media, right? Like that's why I was saying like you actually should try a very simple model on your use case and see how well it actually works. Because it's very, very highly dependent on the kind of data that you feed these models. They are only as good as the data that you feed them on, right? And they can be biased towards something. So that's also an emerging area of research, how to make sure these models don't have the same biases that we as humans do. That's like very important for like more socially relevant issues when you have a machine learning model which is deciding whether to give loan to someone or not. There these problems become very important.
As Elon Musk says that AI is far more dangerous than you think. So what do you want to say about it?
Yeah, I think AI is only as dangerous as humans make it, right? So it's most of the current models, they are not very, I would say, as intelligent as we think they are. Like they solve a very specific task that you train them for. Like sometimes it amazes you, right? It surprises you. Wow, this is like, I did not expect it to be this good. But that's because you trained it to be in that particular way, and it's doing that specific task. I don't think we have achieved like general intelligence where it's your model is thinking on itself for like or trying to harm humanity, right? Like it depends on the use case where you employ that AI, right? Whenever there's a new technology, there are negative use cases, positive use cases. Like similarly for like bias, right? Some models which are not doing anything harmful, they still have some kind of bias in them based on humans' social stereotypes against certain things. So I think it's up to like whoever applies these models to watch out for these things.
Based on some of the things that we've seen, many of these data-driven models, they rely on large amounts of data that is integrated. So for instance, for credit scoring, you need data from banks and then telcos, et cetera, et cetera. But in developing countries, you either don't have that kind of data or you don't have that cooperation. Based on that, what kind of ML applications do you think we might expect at least to be possible potentially in Pakistan or similar economies?
For a new product, it doesn't have to involve AI from day one, right? You can start with some kind of heuristics, and you can start with an assisted approval process, for example. Like you have a very simple heuristics-based model which is giving suggestions, and then there's a human who is also in the loop, who is actually reviewing these suggestions. So it's more like an assistance tool than a final automatic approval process. When you don't have data, even that is useful. Like for example, your heuristics can rule out some bogus applications, like which don't have much merit. So a human reviewer doesn't even review them, right? So like you can reduce spam that way, and gradually you can improve it so much so that a human is not needed at all as you get more users, customers, more data.
Right now, there's a huge disadvantage between developed countries or US, Canada, and other countries as compared to Pakistan or Bangladesh. We currently do not have the amount of resources that are required to deploy or have a production-sized ML model, right? So do you think that in the future this will get better, or do you think that this is an advantage of scale that will persist for over time?
Different cloud providers, like they have APIs for some very basic models. You don't even need to train your own model on GPUs. You can just call this API. But yeah, there is like a cost associated. They are all based on they're all for-profit companies. So yeah, I think that is a barrier. But I mean that's why I'm saying like if you still develop a product which is solving some customer's use case, and you don't need to start with a very large model which is trained on GPUs. Like you can almost always start with something which is not very complicated.
Some of the models are privacy leaking, right? Data leaking models, right? So for a country in Pakistan where we know that our main mode of communication might not be English, right? So if we train a model on Urdu or in a native language, we know that there can be data leakages or privacy leaking models that can be at play, right? So do you think that that's a bigger blocker for us?
So I think a lot of these fundamental models, like large language models out in the industry, they are trained on kind of open source data where they have the license to use that data. When you do use some actual user data and you are worried about the privacy, then there are techniques like differential privacy, which are basically based on statistics and noise, which guarantee that if you include this data, there's like almost no chance of this data being leaked. So what basically happens is like you don't feed it actual users' data, you add a lot of noise to that data, which makes it almost impossible to be recovered later on. So yeah, the idea is like if you have like 100,000 users and you add like one more user with a lot of noise in their data, then it would be very hard. Yeah. Of course, like if your model is just trained on one user, that's not going to be private.
With the advancement in technology, there are a lot of GPUs coming in. So, for example, we have been working in a startup of robotics where we have trained a few models. But then what we face issues on the edge. Of course, there are constraints, memory constraints. And then there is a new version coming in from NVIDIA or some company, and then we have to shift towards that. So, it's more or less an unavoidable problem, right? But how do you see the advancement in embedded AI? I've seen few controllers running now TensorFlow Lite or something like that. So, do you think that's sustainable and more for the future?
Yeah, I think they're working on developing some protocols for having defined schema for these models. I'm talking about neural networks specifically. So they're working on some. I think there already are some kind of shared schemas which are kind of open community standards that if you define a model like this, then we will provide a library which can customize it to be implemented on an FPGA or this specialized chip, whether that's from NVIDIA or some other company, which can accelerate these things on the edge. So yeah, I don't think there's a single shared single schema which everybody's agreed on, but I think that could be one way of making it easier. But yeah, there's still the problem of every hardware provider has to provide a way of translating these neural networks into the hardware implementation or embedded implementation. Thank you everyone for coming. It was really nice experience, and thank you Daftarkhwan for giving me this chance to be here. Hope it was helpful for everyone. And feel free to reach out to me on LinkedIn if you have any more questions. And thank you once again.